Okay, so the meeting is now being recorded, and by continuing to be in this meeting, you're all consenting to be recorded. So good evening and welcome you all to our Module 2 webinar today, which is the third in the series of 5 webinars that are planned for this course and the semester, Data 460, Section 6980. And I'm going to skip the next slide pretty much because it's about the etiquettes, which we are a small crowd here. So by all means, feel free to, use your video and come up and don't have to, you can interrupt me anytime, ask me questions anytime. The only thing I would suggest is if, just limit any distractions around you, or if there's anyone talking around you, maybe you want to go on mute, but otherwise feel free to be off mute. Feel free to be on camera, and we'll hopefully we'll get this through within an hour's time. I don't intend to take this or take this longer than an hour, 15 minutes max, but hopefully we'll be done. Depends on if there are any questions you guys may have. And we'll again be meeting again 2 weeks from now. So please mark your calendar accordingly whenever you get that invite for the next, meeting. Okay. All right. So our agenda today, we'll talk about sentiment analysis. We're doing a little different here. Sentiment analysis, a little different than what I've typically done. Steve and Ayo and Teo. I'm going to, walk you through one of the projects that I personally worked on for sentiment analysis. And there are a couple of reasons why I'm doing this walkthrough and not take you through any concept or any kind of a supplement information. It is a supplement, of course, but it's not really kind of a theory, but more so like a little bit of a practical. And that's because, I know at this point in time, Steve, you and your classmates have gone through so much of material already. You've watched tons of videos. You've gone through lots and lots of material, reading material on NLP, on sentiment analysis, that I don't think that, need to bring in anything more. Of course, sky's the limit, as I say always, keep looking for more and more resources and stuff. So I thought, let me augment this or have something to bring on a little more practical that I can share. And I couldn't think of anything better than a project that I did on sentiment analysis. It's going to be almost 7 years back now, but it's still so relevant. And still that, and you'll tell me that it's relevant. Those packages are all still there. People do pretty much the similar kind of sentiment analysis and all that. So that's one of the reasons I'm kind of bringing that up. Secondly, I know you and your classmates are so close to your capstone course, right? Where you will be working independently on a project, and you would really want to see what kind of a depth or level of analysis that you really want to get to, right? I mean, it's important, right? You are going to be in a final course of your degree, and you want to really make full use of it, not just for the sake of passing or getting the grades that you need, but just beyond that, right? What you really want to do. This is going to be the perfect time to, use this as your playground to, practice any skills or anything that you've worked so hard for the last couple of years to few years, getting onto this degree. So the capstone project is going to be one project, one course that, or one capstone course is going to be one of those courses where you can use all the skills that you build and do some comprehensive analysis. So that's another reason why, I mean, this may not still be a very good representation, but at least it will give you an idea of what level of analysis and how deep you want to really go with some of your project work in future. Okay, so that's what I want to kind of get to. So it's going to be more show and tell, really, and than anything in that particular segment. Then we'll talk about assignment 2, and we'll go over any questions you have, or just giving you some idea or or idea about the assignment too. And then, of course, any questions you may have towards the end. But in any case, please feel free to ask me in between, interrupt me, absolutely. We are a small crowd here, so let's take advantage of that. And Steve, especially you, please feel free to chime in at any time or with your questions, with your comments. Okay, and Ao and Teo to you as well. So with that, before I get to sentiment analysis, I want to do like a quick retrospective on your weeks 2 and 3. First and foremost, well done on your assignment. Absolutely. And you kind of got a hang of it, right? Like if you are following all the instructions, if you're using all the best practices in AWS as what you have done in the past, then these assignments are not going to be that difficult. And at the same time, of course, like when you're going through it, if you're understanding them, then responding to those questions that you're asked in the assignments are not going to be difficult either. So, everyone done a fantastic job. So keep up the good work. And yet again, week 3 discussions was one of the most exciting discussion weeks. So you kind of, you all continued to embrace the spirit of participation and engagement, and you're reviewing your classmates' posting and addressing and asking questions and addressing, your classmates' questions and any comments that I would have. So I think you are getting into that, and you're keeping up with that. But of course, as I said, there's always an opportunity to do better. And I think an opportunity that I see that we as a class have is posting your initial or post your initial submission as early as possible so that you can get your classmates involved. You can get involved with part engaging with your classmates on their postings as well. So that's an opportunity, and I think that would really hit the mark there, and we will really reach the gold standard here for our discussions. And of course, as I hope you all are taking advantage of these webinars, either by attending, and if not, I completely understand the hardship that some of you, or the challenge that some of you may be facing, being part of it or being here physically present on an evening. But I hope you are still taking advantage by viewing the recording of these webinars, which should be just an add-on and augmenting or supplementing what you go through module by module. Okay. So a couple of things about week 3 quiz. So there are a couple of questions on this quiz, and I'd like to thank one of your classmates who took your quiz, Mary. She took this quiz, and I know, Steve, I think you as well kind of brought up about the week, or maybe the assignment and the week 3 quiz. So I think you both did a fantastic job of bringing in something early that I can take a look at. So from a quiz perspective, I know there were a couple of questions here, which is the first one being a bidirectional RNN. And this has actually a couple of answers are correct. So if you get either of those 2 answers on this one, even if you do not get a full point, I will give you and award you full point for that. Okay. So I'm looking for 2 answers out of these 4 are absolutely correct. And I will give you full points for that if you just pick either one, because you can only pick one answer. And I'm not giving away the answer in this one because I know there's some who still have to complete this quiz. I'm not giving the answer away. But again, I kind of, I saw that, yes, there was more than one answer was right here and not just one. Okay. So that's one. Number 2, there was a question on positional encoding, which was also brought to my attention that, this was probably not part of any of the readings. And I kind of digged into that to find out that, yes, the department had pulled out mistakenly this particular reading material, which had discussed positional encoding. So again, we don't want to kind of bring that on and make you go through the quiz again. So I'm going to give out the answer here, and it's already marked and it's highlighted here the second part, the second option there, which is a positional encoding, is a dense vector that encodes the position of a word within a sentence. Okay, so again, there's also actually a very short video that I shared with Mary that I can share. I'd like to share with you all as well about positional encoding, especially if you're wondering what it is. And for many of you, it may be a new term, or you may not have seen this before. So I would like to kind of share that, a very short 5 minutes video that you can take a look at. Of course, the video is a little longer, but the first 5 minutes actually just gives it away and tells you about positional encoding. So I'll share this in the classroom as well, but just want to know that if you have marked this incorrectly in the quiz, I will give you full points for that. Okay. Any questions on quiz? Steve, do you have any questions?
No, I don't. Thank
okay,
you.
Excellent. All right. So coming to sentiment analysis, right? We looked at this slide last time, and I know I went through this list about what humans are good at, especially from a language perspective, right? Ambiguity, creativity, common knowledge, diversity, empathy, analogies, storytelling, and all that, right? And what we are not so good at. There's one more aspect that we humans are good at is sentiment, right? Now, there's a difference. There's a subtle difference between empathy and sentiment, right? To empathize is identifying someone else's thoughts and situation, right? Whereas sentiment is more personal, personal emotions, right? About a particular situation, or about what's being talked about, or whatever that could be, any kind of a sentiment for anything around you. That's personal, right? So that's a subtle difference between empathy and sentiment, but we humans are pretty good with that as well, right? And which by, we can understand a sentiment while someone is speaking in front of you, by so many things. There are so many pointer, like or you could you can probably read someone's face, you can read the words, the weight is the tone of the word, the vocabulary being used, all of that, right? And you can probably get to know the sentiment of a particular word, or a set of words or sentences. And we're pretty good with that, right? Even sarcasm, we can pick on that very well. Hey, did somebody say it with sarcasm, or somebody did really say it with exactly? So we know what could be at face value. So we humans are good at that, and are machines really good at that? Well, we're trying hard, right? But with the latest, the advances that we've made very recently with large language models, and with all that and all the hype about, GPT models and the other large language models, we certainly does again, I think it has revolutionized the way we can do certain NLP tasks, right? And one of the NLP tasks is sentiment analysis. So something that we've been doing for longest time, as long as as NLP has been around, we've been thinking about and sentiment analysis, or doing it in some form or some way or the other. And I think we can now probably, in fact, it will even go beyond and maybe get more and more closer to how humans can interpret and can do any kind of sentiment analysis, right? So that's what it's about. And so it's been a very, very interesting topic all along, right? From anybody who learns about NLP knows that, it's not just about understanding what does the sentence have, how many nouns, how many verbs, how many parts of speech, which words being used frequently. All that is just pure analysis. But what is the outcome of that? What is the result? What are we trying to get out of that, right? That's when sentiment analysis is most really applying all those skills and tasks to understand what is underneath these heap of words, heap of sentences that you want to really get out of it, right? You have all these hundreds of surveys, thousands of comments, thousands of things being talked about in the media. How would you quickly know what is being talked about and and what's the sentiment like of that, whether it's a product, whether it's an issue, or so. I'm going to walk you through one of the projects, and it's more of like, show and tell, basically, about the projects. I will not be able to get into a really lot of details because we literally spent like, a long time, almost more than month and a half. I personally spent on working on this particular project, and it was very timely when I did it, and you'll know exactly reason why, because I was looking for what could be the best. I was looking for, applying my NLP skills that I'd kind of learned or kind of was using, and I wanted to do more. So I said, what could be the best, thing? And so the year was 2016, and you probably got it. It was the year where a new president was going to be chosen, and there were two candidates that were up there, Donald Trump and Hillary Clinton, who were, the candidates for this election. And this election was popular and famous for so many reasons. Again, I don't want to talk. I want to be very objective. Just talk about it from a sentiment analysis, then talk about these candidates in any way. So I don't want this session this evening to be political in any way, and that was not also my intent when I did this project, because my intent was, hey, what is it? How good my sentiment, how good the analysis could be, and once I know the result of this particular election. So in the run-up for the elections, for this particular election and the result, I wanted to see what was really being talked about, what people talk about in social media, and the type of analysis you do really made sense, that, what the outcome should be. How does media really come up with their exit polls and say that, hey, this could be a probable winner, right? And this is what the sentiment is. So I was very curious to see how I could do it in a very, as I said, not in a very large way, because most of these companies that are involved, they do it in such a fancy way and have a lot more resources. I did not have all the resources, but but I just wanted to do it on a personal front and see how this project comes up. And actually, I did also demoed it to a meetup as well. So what I looked at for this particular project was, I thought about Twitter right there. Twitter was a very popular platform. It still is, by the way. And one of the reasons why I've listed all these things that you see on the screen here, it has got 396 0.5 million users globally. Of course, less than Facebook or Insta these days, but still, Twitter is still a very popular platform. More than 500 tweets. It should be 500 million. Sorry, 500 million tweets are sent every day. I'll correct that. 50% of tweets in 2020 came from Gen Z users. When Gen Z users, as you know, Gen Z is anyone who was born between 1997 and 2012. So being used by a lot of young crowd. I mean, most of the Twitter users, as you can see, is that 18 to 55% of the users are between the age of 18 and 34. So very heavily used by young young citizens of the country as well as of the world as well. And most importantly, at that point in time, Twitter, especially I'm talking about 2016, when it had good API development and good support from API perspective, and so it was pretty mature. The API had been there or around for quite some time. So I thought, okay, this is something that I can really make use of. It was not too difficult, and so we kind of I thought about Twitter being used. So just laying out some of the major steps on this project. First of all, thought about R. Yes, Python again was gaining popularity, but R was still one of the go-to languages, right? Very, very simple, very quick to install, quick to know all the packages. There were thousands and thousands of statistical and machine learning packages that were supported in R. So, I couldn't think of anything. Today, if I do it, maybe I'll do it in Python. But those days, even today, I still love R, by the way. So nothing against R or anything, but it's just that Python had not gained that popularity that it has today. Um, Install the relevant packages and establish connection to Twitter from R. So that was another important step there to ensure that you can talk to the API, you get that connectivity established. The third and most important step, which I really spent a lot of time on, is gathering the tweets and reading the text. And you'll say, well, doesn't the API, you just said API is matured and very easy to set up. Yeah, easy to set up. But again, there were a lot of restrictions on how many tweets you can gather in one session in every 15 minutes. Then it would like kind of block you for a certain period of time. Again, you need to restart it and get in more and more tweets, right? So there were some challenges with getting all the tweets that you want without missing out any information or any of the tweets. So but again, that's a discussion for some other time in case you're interested. But it was pretty. But I was very happy with the outcome of that. I spent a lot of time. I used to kick off this process in the morning, and it used to run through the day and all of that, which was very, very exciting. In those days, I was kind of able to do that, and I liked doing it and seeing how I could just kind of keep getting newer and newer tweets in my system throughout the day. And then, of course, cleaning the text data, that's where you apply your NLP skills. You talk about all those NLP tasks, right? Removing stop words and all the sketch characters and, the spaces, and you do stemming or you do lemmatization on all of that, right? And then, of course, the most important piece, right? After all that, performing text and sentiment analysis. So these were the major steps in this project here. So the number of days that tweets were collected were 39 days. So I did all the tweets were, kind of collected from October 1st all through the run up to the election until the November 8th, right? Wanted to see how things were shifting or what the results that came out on after the elections. Did it really, did it reflect what was being seen on Twitter for both these candidates, really? Was it like a one-to-one mapping saying, oh, yes, this is what we saw, and that's why this candidate became the president or did not become the president, right? Would it give me that kind of an idea? So again, the number of tweets collected, 141,000. So that was a pretty good number in my mind. And this is this were no retweets. So only the original tweets, which would tell me, hey, how many times this tweet was retweeted, right? So I didn't want to kind of duplicate it, right? There would be tweets, and hundreds of users would just tweet the same thing over and over again. So cut down on all the retweets. So this was pure original tweets. There were 141,000. Average number of tweets per day was 1,670. There were 65,000 users screen names that were found within this data. There were users around 60,000 were users data. I'm sorry. So out of these 65,000 screen names or users, I was able to get some more relevant data about the users, like their location and so on. For 60,000 of them, and 5,000, there was no information for them. And then the number of working sessions, again, this was the working session. So, this was my working session about, and I had a couple of people that, who kind of also wanted to work with me, but that's pretty much, irrelevant for this, particular discussion. But again, there was a lot of data that we kind of collected. So, we did, so first and foremost, we did the tweet search and download. Where we developed methodology for incremental gathering of tweets. We used API provided techniques to add missed tweets. So every time we run a process, and anytime we run it again, we found out that there were certain tweets that were not part of the original package. So yeah, we had to kind of do some, as I said, we had to do some jugglery there to ensure that we get each and every tweet for each and every day. So that was a little bit of challenging, and we had to do something programmatically to ensure that we get that. we included downloading additional users' data. So we found out there was a way to kind of get some extra data for each user, which I just mentioned, there were 60,000 users. And after gathering all that data, of course, we ran through all different statistical analysis like candidate-wise data, daily data, weekly data, weekdays data, or any user summary. We conducted correlation analysis and chi-square test. We built density graphs for comparison. And you'll see the charts, by the way. So I'm just kind of just putting it all in one sheet here to kind of show what was done at every, these were the four main sections there. Then we did the text analysis portion of it, where we did all the cleanup. We did the stemming. Actually, I kind of did a mix of stemming and lemmatization, to be honest with you, because the stemming was really, really cutting down on those words. It cuts down the when it gets to the root of the words, it, as you say, it cut down the suffixes, which was really not, doing it a good job. Actually, and I felt that when you do sentiment analysis, if you do pure stemming, many a time you could lose the context. You could, because the way it chops certain words and it gets to the root of those words, it really chops the suffixes, and sometimes you lose the context for your sentiment analysis. So I suggest, and this is just me, guys, I mean, doing some of the projects in sentiment analysis and text, I found that I could just maybe, I did play around with stemming and without stemming, and see what really works. And I think if you recall in my previous webinar too, I kind of mentioned this, how you may want to really try things out when you just don't want to do or go all out and do all the NLP cleaning tasks as you learned, because many a times certain combination of tasks work very well and certain doesn't, and stemming is very, very tricky. So stemming and lemmatization, or not having both, or both, how you can really get to a good data that would still retain its meaning, especially for sentiment analysis. You can do terms frequency, you can do associativity of words. We did topic modeling, we did clustering, and then the main part was sentiment analysis. And this was a huge part. This was the main, right? Because this is the core of the project. This is the heart of the project. And this is where we spent a maximum amount of time, where we built a lexicon and all of that. Anyway, I don't want to go through a lot of clear text here. So let me show what was the outcome of a lot of these, and I'll talk. I'll put or I'll do a voiceover on those charts or the slides. Okay, I'll use some of the information here. So going over this is just a quick view of the downloaded API data, right? This is like what each tweet data had, and this is just a data frame in R, like what each tweet and what all the different columns it had, and some of the values there. So just showing you that it had, basically the most important thing is what was the search string, right? Each tweet we had to kind of annotate or add a search string saying, when we searched for Donald Trump, these were the tweets. And so we added Donald Trump to it as a search string. Then we searched for Hillary Clinton, and then we had a group of tweets that would come up. And then we used to tag those tweets with Hillary Clinton. So we know that, hey, this were the tweets when we searched Clinton, and these were the tweets when we searched Trump. And then the text of the tweet, how many times it was favorited, how many times it was retweeted. But again, this was still our original tweet. So none of these were really any retweets, none of that. So all those duplication was completely, and all that noise was taken out of the data, okay? So then once we've kind of downloaded this data, we did like a, missingness map, right? There was a nice package there, and I believe there have been many more now that has come up that you can do this even better by looking at the entire, it gives you like one graphical view of your entire data set. And Yeah, I mean, it could be as large as 140, 141,000 data, and it could give you a graph of everything that you can see here. Hey, where there is data and where there isn't data, right? And I'm showing you a very small snapshot of 50 records, like how it kind of comes up, and it shows you that, hey, wherever there is red, meaning, the data is, there's a gap in data, there's a lot of data missing, and a green meaning, hey, you've got data there. So a lot of columns were really filled very well and yet no issues, but there were some columns that were, a huge percentage of was missing data, which was really not useful in any way, like the latitude or longitude, or reply to SID, reply to a screen ID or a user ID, and reply to, screen name. There were like many, many gaps, which again, didn't really bother us because they were not the ones that we'll use. We looked at the variation of data within each of those columns. And we looked at, like, say, search string had two two data points, two data values there. One was Donald Trump, one was Hillary Clinton. So you see that the leftmost bar there for the search string has the two values, like 50, almost, it was 50-50. The number of tweets that we got for Hillary Clinton was pretty much very similar for Donald Trump as well. So they were both equal. And then there were some certain columns that were so much of variation because the data changed, but there was still some data. Some would be copied over, but there would be a lot of variation or changes to it. So, and then of course there are data that was not available at all. So you'd see that red was kind of indicating that, hey, there's no data in it, right? And if there is any other color than red, that means there is data in it. So again, making use of those packages or charts of how you would want to kind of view your data and see what is in your data first before you kind of start your analysis. Then you would apply something called correlation analysis, right? So I applied correlation analysis and said, okay, which are the ones I can really get rid of just because they are so highly correlated to each other? Like a retweet count would be so highly correlated with favorite count, right? A date only field could be probably, maybe it's not that correlated with time only as much, but look at favorite count and retweet count. They are very, very highly related to each other. And maybe, either I just take both of them off, but I needed retweet count more than the favorite count. So in case I'm doing any analysis on the number of retweets. So then we looked at, the tweets by each of the days of the 39 days. We looked at the number of tweets for each of the candidates. Like, there were days when Trump had more tweets. There were days when Hillary Clinton, the tagged with Hillary Clinton had more. So there was like a good neck and neck race, as you can see. Both for Hillary Clinton, although Hillary was a little bit less than Donald Trump, as you can see that the blue and the red line showing you the average for the two. And they're pretty close to each other, guys. There was not much big difference, as I said. But again, this is just one of the kind of analysis. We said, okay, how many tweets did one was higher than the other, or maybe they were just neck and neck. And we thought it was pretty close, and in terms of the number of tweets they had. Then we looked at, what particular hours we looked at, and these I'm just showing you the final 2 hours of the day, which is 11 o'clock and pretty close to, between 10:11 and 11 and 12. As you can see here on 23, which is close to between 10 and 11, at the 11 hour, there would be more Clinton tweets than Donald Trump tweets. But look what happened during the last hour of the day. There would be more Donald Trump tweets. And although I'm not showing you all the charts here, but we did some analysis on, like, what are the hours or the days that, these tweets are happening. And we saw that there were a lot of tweets that would get generated during the last couple of hours of the day, which again raising some suspicious activity or behavior, or we just, just curious as to what's going on, right? Why would somebody be tweeting? Is it that people are done with their day and they get onto the Twitter and they start tweeting, or is whatever? I mean, just curiosity. So that's why we looked at the last, these kind of really came out of in our analysis, and we really did discuss about this as to why, we are seeing this 2 different hours. So as a matter of fact, we took this a step forward and said, okay, let's do a density analysis on this, right? And what we did, we took the tweets and we divided the tweets which had got the retweet count, which meaning there were certain times like the retweets are generated and sometimes they were pure original tweets. And again, they were pretty, very, I mean, if you look at the density charts, even though you see the cream colored is where it's not a retweet, it's the original tweets. And the green color is the tweets that retweets. Basically, these were the original tweets that have been retweeted multiple times. As you can see here, again, not a big difference. The chart on the top is for both Hillary Clinton and for Donald Trump, and the two charts at the bottom, the left is for Clinton and the right is for Trump. And again, this was more from doing and making sense out of the density of tweets during the final hours, during the day of debate, right? During the day of debate. So we looked at what was going on in October and November, those 39 days. And then the bottom two charts, we are looking at only the day of debate, like the last hours almost before going to the polls. And then the other kind of analysis we did was looking at which day of the week that which day of the week that each of these candidates were getting the tweets, right? Meaning, like in the tweets were the people were doing tweets on Donald Trump or on Hillary Clinton, and what were the max days that it happened, like on the days when. So you see this color codes. The color codes indicate certain threshold, like the blue indicated certain threshold, like maybe 11,000, right? So if you see the blue color, they're in multiple places, right, across Donald Trump and between the two candidates as well. It's just the threshold. That's all it is showing. But it just gives you an idea as to which day of the week certain candidate was tweeted the most. Like Donald Trump was tweeted the most on Mondays. Don't know why, but yes, it is what it is. It's just the analysis, right? And again, as well as if you see Hillary Clinton, pretty much, the graph was almost like even across all the days, except for a Sunday when it again showed the highest amongst all the different days. Whereas for Trump, the highest would be on Mondays. So again, there were lots that could be talked about. But again, we'll leave it to that. We'll not get into any political or any that kind of discussion. Again, we'll just be objective here. So then we looked at what devices or platforms these number of tweets were coming out of, like which device were being used for these tweets. And to our surprise, when we did this analysis, we saw there was more coming from the web, from computers, than from iPhone or from Android or from Facebook or any other device that were there. So that was little surprising. Did not really expect that. So we thought there would be more from iOS and iPhone and Android, but then again we're seeing more from the web. But again, it is what it is, right? But just kind of saying that there were a lot of users on computer that were using the Twitter app to tweet, which was surprising. But hey, that's the analysis, right? That's what the data was telling us. And of course, when you're doing NLP kind of task, you would probably not keep away from word clouds, right? We want to kind of develop, although it's not a great analytical tool as such, I think it's just a good, just getting a good quick view of the words that could be there as part of the tweets, and that's all we were looking at. So we looked at a couple of packages that were, helping us to build word clouds. Like we built one for Clinton, which one of the major words in Clinton's tweets, which not a surprise, but it was Trump. The other words like email or Clinton or vote or WikiLeaks, FBI, or an ampersand for it's amp, actually is an ampersand, it's an and sign. But again, so these were all the different, there's the word cloud for Trump as well. Then we did the analysis for finding out which were the top screen names or users that were, that tweeted during this time period. And if you glance through the list there that we got, you will see that there were more media users or screen names, or like all day politics, Trump feeds, then the Trump blogger, or the CNN manager. These were the top users, the screen names, which gave an indication that more of these tweets were coming from corporates or media moguls than from any other place, from actual individuals like us, because we did not see many individuals that were really coming up on this list as our top 20. Even we looked at even top 25 or even top 50 did not have really some individual. Maybe some popped up here and there, but there were not many. So again, giving an idea that there was a lot of corporate involvement here, and media involvement into this tweeters in those days running up to the elections. We looked at the tweets again, the network, like for each tweet, where it was really going, which users it was really hitting. And there was a lot more that we did than this single chart that I'm showing here. Again, we were trying to establish like who is tweeting to whom, right? And is there some kind of a relation or connectivity that we were trying to establish there? We looked at the clusters, right, of friends and followers, like we put the friends count and the followers count on two different axes, or maybe in this using it as two dimensions, and then looking at the different clusters of users and where they fell in this particular 2D chart here. And you can see that there are a lot. One of the biggest clusters there in blue is the one with the highest number of followers and with the friends count. The axis is, by the way, the log of friends count and the log of followers count. So it's the log actually. And that's why you may think that, hey, why is somebody's count of friends count is 14 and the followers count is 10? Why would they be so high? But no, that's the log actually. So that number is actually really high. So the blue cluster was that really the dominating cluster, but then there are other clusters as well that are equally big. But then again, you see the dominant cluster there that was probably doing all those retweets to their friends and followers as well. Again, sorry, I'm kind of going through these slides and pretty quickly, but Steve, if there's at any point any questions, if you want me to stop at a particular chart, I just wanted to basically show and tell here, and that's why I'm taking you through this. But my main intention is to kind of just show you and your classmates here, like the kind of analysis that how deep you want to go with your analysis. And we haven't even hit to the sentiment analysis yet. But any questions, Steve, at this point?
No, not at all. It's very interesting. Thank you.
Okay. Okay, I'll keep going, but please, okay, if anytime you feel like, oh my God, this is too much, where did we go with this? But yeah,
awesome.
we're getting there. Okay.
All right, thanks.
So then we do like a word frequency, right? Okay, of course, we want to find out the top 25 terms that the Clinton tweet had, right? And of course, Trump comes up on the top of as one of the topmost terms there, which is fine. But looking at the number of tweets that some of these words had, were part of, amazing, right? Again, making use of all those packages. So one of the things I would advise you all is to look for the packages, look for things that you want to bring up, and then look for what packages, what kind of a support you have in that tool, which is going to help you build this. Like, like for example, this particular chart, and I'm thinking about all the different packages that we used to really had to invest or research on to say, okay, which particular package is going to give us like a beautiful, popularity of top 25 terms kind of a chart. And we can easily show this in a nice form that is going to look pretty. So this is not a handmade chart. This is a chart that are all these charts that you have seen thus far and even in this further are being built by one of the packages in R that have been used, right? One of them. Like there are multiple packages we use, like tidyr and stringr and tidytext and so on, and multiple of them that we have used this. But again, the idea was to make sure that we can just showcase all the things that we want to do. So again, these are the word frequency charts that we came up with. We looked at the associativity of the words, like we said, okay, at least 15% of association between words, if show me all those words. And again, this is a very little snapshot of that. There was like a huge chart, so I just took a little snapshot. We increased the associativity to 15% to just show only the few words there. But then there are certain words that were so highly interconnected, like FBI and email were like so connected, and the reason they are in a little different color than the others is because they were part of multiple tweets. And we know, right, we know that what had happened at that point with all that controversy about the emails and with the FBI and all that was going on in the Clinton tweets. And something very similar that we saw in tweets that were related to Trump, where it was about Hillary, it was about GOP, it was about debt, and so on. But some of these words were like highly interconnected, meaning they appeared in pairs or within a single tweet multiple times, right? So that's what this analysis was showing us, and it did not really give us a whole lot, but just to kind of get an idea, can we get anything out of this, right, of this associativity? So we tried multiple different thresholds to seeing, hey, what if we increase the correlation to 50%? Which words are really strongly correlated with each other that we can bring up and say that they always come up together, right, in a particular tweet, or they're always in a single tweet, they are always there. So that's the things where we were trying this out. And I tried it, and I just brought this. I thought with 15%, I was able to get to a little small picture here to show. We did topic modeling, right? You probably heard about topic modeling in LMP. We looked at all, maybe just looked at 5 different topics that, Clinton tweets had. We looked at the same, what were the number of total tweets per topic for Trump, like all the 5 topics. And they're just in different colors, just showing you what are all the different topics. We also looked at how the topics, were discussed, different topics being discussed on each of the days. Again, those 39 days, how the topics were being discussed. So all those different density graphs, like it is showing you the proportion of topics in percentages that were being discussed during each day. And it kind of shows you like a little really nice chart. And of course, if I expand this, it really came out very well when I had to kind of put it in a full screen mode. And we could just think about, hey, it looks like emails and FBI are probably talked about the most towards the end and so on. So we were able to kind of do all that kind of analysis to say, hey, yes, we all know that, right? Towards the end of the campaign, that whole email thing was kind of, blown out, and there was a lot bigger controversy, and then things were happening at that point. So again, this was just purely looking at the data upfront, doing some text cleaning in a certain way, doing all those kind of correlation analysis, doing all this topic modeling, looking at the different counts, doing all those different statistics. Finally, we get to the sentiment analysis. So first, we did multiple types of sentiment analysis. I think we did like almost 7 to 8 different types here. And I can probably, I'll be showing like 5 or 6 of them over here. And just interest of time here, I'm looking at the clock and I know it's 8:20, and I'll just kind of just go through this quickly so that Steve, we don't have you, and Ayo and Teo, we don't have you for too long. But I hope you'll be okay if you go like little few minutes over. But I'll try to go through this as quickly as I can. Okay. So sentiment analysis, we looked at all the exclamations. So this was unigrams analysis, looking at purely all the exclamations that had. Again, just looking, okay, just making some sense out of it. Do we or can we? Not sure, but we just thought, let's do it. So we looked at what certain words came out, like Clinton, Trump, Hillary, president, America, wow, woman, her, all that, lies. And these were all some of the exclamations that were used in Clinton tweets. Then there were some exclamations being used in Trump tweets, right? Again, multiple exclamations. And of course, their names with the exclamation topped all other exclamations in the tweet, which was kind of funny. But again, yeah, that's what these tweets contained, anyways. Then we looked at the polarity of each tweet. Like each tweet, we looked at the different words and what was the polarity of each word, and then the total of all the polarities, right? For let's say it has got 3 words, and if one was 2 words were negative, one was positive, the sum of it could be 0, the sum of it could be positive plus something, or sum of it could be minus something, right? When you look at this, when we put it all the tweets together, we found that if you look at the middle line is 0, right? So if you see this particular one, Donald Trump, right on the top one, you see that Donald Trump had most neutral tweets, meaning all the words when put together, the polarity was coming to 0, which was kind of more even, kind of tweets. Hillary Clinton was pretty similar. The charts are pretty similar, but Hillary Clinton had more -1 and or I think minus, probably you could say -2 are negative. Like little bit of a negativity was the highest in the tallest building in Hillary Clinton's chart was -1, -2. And of course, this next one was neutral. So we kind of looked at all the different tweets and put this polarity chart together. Then we looked at, the polarity chart in terms of like very negative, how many neutral, very positive, and negative. As you can see here, both put together, there were more negative tweets than anything. They were most negative. Clinton had the most negative ones. Very negative was pretty high, and Trump had very negative, which was little lower. Again, doing some analysis on where things were being headed, right? So if the media and if individuals were really doing some analysis, and you were seeing some exit polls coming out at that time, which was favoring one or the other, they were constantly looking at this, and maybe even some better charts than what I'm showing here. Maybe they were doing some more better way of kind of handling this, or maybe using much more data than what I was looking at to kind of come up with those and I know it was still a surprise to many whatever the outcome was, but again, there were certain media outlets that was really giving out a very, very accurate picture of what was going on based on what they were seeing in many platforms, not just Twitter, but they were looking at multiple platforms, I guess. So then we looked at, okay, what was the negativity over time? So we took all the negative and very negative tweets. So what you see, the green line is all very negative. The red line is all negative. And then the black line is the total of the two. And we wanted to see going across, what is the negativity there around. And pretty much they're neck to neck again, not too different in terms of, total negativity there, as we have seen, which one could be little higher than the other. But we still looked at both negativity. We looked at both positivity as well. As you can see here, the positivity for Trump was still at high towards the end, but towards the end, in the run up, the last few days, when all that FBI and the email thing kind of, blew up, you see the positivity went down on that particular day. That whole positivity chart on the October 25th or 26th, I think that was the day when things went downhill. And you can see the positivity really decreased at that point, and it did not go too high after that. So again, just kind of seeing that, based on the result that happened, what was really happening in the background, only in one media. This is again, one social media, only on Twitter. Then we went ahead and looked at the emotions behind the tweets, like how much was the anger, what was the biggest, like in Clinton tweets, trust was pretty high. The trust, or that sentiment was pretty high in Clinton's tweets. And of course, all others, like the anger and anticipation and disgust, was kind of there, but trust was pretty high on the chart there. As far as Trump goes, we saw that surprise was very high up there. And again, followed by the trust, which was a little lower than that. But again, look at the surprise bar there. And again, the axis, if you look at the axis, is a little different. Here, the axis for Clinton goes only up to 35,000 or 40,000 or so. Whereas you see here, the axis is 60,000. So this surprise element was pretty high if you look at Trump's tweets. Then we put the same emotions, or at least the top ones in all these two, both Clinton and Trump tweets, on a scale, on a range there, chronologically. How were they really going up and down? Like how much was surprise going up and down? How much was trust going up and down? How much was fear going up and down, and so on? Okay, so again, these were the different types of analysis, and as I said, we can just keep going here, but we still went ahead and did little more than this. But this is the type of analysis that you would really want to get into, and there's a lot of code. There's almost like 2,500 lines of code behind this, and I'm just talking about R, which again, it's a pretty powerful kind of a tool and language, that if you talk about 2,500 lines of code, there's a lot that was done. And if there's interest, I can probably at some point kind of even take you through that. But there's a lot that you'll have to really spend time on to come up with this kind of an analysis, which is really going to be helping you a lot to, again, practice your skills that you've learned. So keep that in mind when you are, getting ready for your next, capstone course, okay? The final course. So again, the food for thought, how would you take your learning about sentiment analysis forward? What is your plan to practice the knowledge and skills you have learned during this week? And have you researched areas to find text data sets for practicing your skills, making sure that, so think about all these, while you are kind of going to end this module pretty soon after working on an assignment this week. But before I start talking about assignment 2, any questions? Steve or anyone? Any questions?
No, not for me.
I hope this was helpful and worth the time that we spent so far. Yeah, so looking forward to that feedback, Steve, at some point, and look forward to hear from your classmates as well as to what they think about it. But again, if there's interest, I can take this further, and maybe, if you're part of the capstone, then I'll be kind of doing something very similar. I'll be doing the capstone course. I'll be teaching that course, I think, in October through December. That's my plan. So I'll probably, take the students through some of this analysis and how deep this analysis should be. So yeah, assignment 2, you'll use AWS SageMaker again. You use PyTorch and you use BERT for sentiment analysis. You'll deploy a pre-trained BERT model as an endpoint on AWS. You will then access and invoke that endpoint to classify the sentiment of text data. So yeah, everything is part of the code. So as long as you go through the setup very clearly, you go on to SageMaker, you put up the notebook, you upload the notebook, you upload a couple of other files that you've been asked to upload in a particular directory that you should be uploading it. Bingo, I think. And most importantly, I think, and of course, go through this prerequisite, right? Make sure that there are 4 different links that have been provided to you. Please go through that to understand the code, because there are going to be questions within this assignment that could be answered by these articles and the code that you'll be going through. So there are these. There's one notebook called assignment2.py. Make sure you choose the kernel Conda PyTorch P310. A couple of you, I think probably Steve, you and one of your classmates really bumped into this and kind of got an error because of using the default kernel. So we think this kernel was newly introduced, but again, if you use the right kernel, bingo, it's all good. Okay, so make sure you choose this kernel. I've updated the instructions with this, and there are 2 supporting files. So which, once again, if you just upload these 2 supporting files in a proper place there in a folder, that's all that's needed. And then you make use of assignment2 template.docx, the file that you want to use for capturing all your responses, noting all your responses, and then submitting it. And finally, you've got this rubric, which is also assigned. It was also attached in the assignment folder, and it gives you, points that are being provided for each of the sections of your, template responses. So, ensure that you've gone through each of that and don't want to lose any of the points here. Okay. So, any questions on the assignment?
No, not for me. I did get the error before, and I haven't had a chance to go back into it to run it on a different kernel, but thank you for that information.
Okay, excellent. All right. So let me know if you still run into error, Steve. But yeah, it should be cleared. I saw that the other classmate, Mary, had a similar issue, and she was able to go through this successfully after this. Okay. All right. Any other questions on not just what we just went through today, but any other questions regarding the module or the course so far?
No, not for me. Sounds great. I'm excited to get into the assignment a little bit deeper. I've heard of BERT before, and I'm excited to actually use that on an actual project. So I've got some coworkers that are really big into some analysis, and I'm excited to kind of get more involved in some of their conversations. So
good. Okay. Yeah, just take on any kind of a good project that you, and these days, as I said, the media now, you got lot more platforms than what was there before. I mean, not that they were not there, but they are now more popular, like Facebook or Insta and so on. So there's a whole bunch of stuff that's out there now from a data perspective that you can get hands on. Of course, look at some Kaggle. There are Kaggle data sets that are now readily available, and some of them are pre-cleaned for you. So you probably kind of go through those steps. So yeah, again, there are multiple places that you can go to get this kind of data. But it's really wonderful. Trust me, you'll feel very accomplished and fulfilling experience at the end of it if you go through it in like a full details, like starting from pulling data from any of these platforms and cleaning it up and seeing the real live data, cleaning it up and making sense out of it. You'll get a kick out of it.
Sounds great. And if you ever do anything with the code and want to do a walkthrough with your actual the 2,500 lines of code. That'd be pretty neat to see too. So
Sure, absolutely. Yep. Especially, yep. Whenever you feel like we're interested in it, we can certainly have like a quick session on that. But it's very interesting, and things may have changed. Things change so quickly, and what I may have done, I'm sure there would be a different way of doing things. But again, the concept is that
Sure.
doesn't change much. So there's a lot out there. There's a lot of documentation that comes along with this. So make use of that as well. Okay.
Perfect. Thank you.
All righty. Okay. If no further questions, then I can call it a wrap. And thank you for staying over. We went 5 minutes over, but I hope it was all worth it at the end. Okay. So good luck
Yes.
with the assignment. And
Thank you so much.
thank you, Ayo. Thank you, Teo, for staying.
Thank you so
Any
much.
questions
Thank
from
you.
you guys or anything that you'd like to add?
Yeah, nothing from me.
Okay. All right. Thank you. Thank you, Teo. Thank you, Ayo. Okay. All right, guys. Thank you. I'll see you in a couple of weeks for Module 3 webinar soon. Okay. Take care. Good night.
All right. Good
Thank
night.
you. Good night.
Bye. Whoa.